Okay, so let's talk about Rinne and Weber tests in otolaryngology. And the idea of this test is a bedside cheat sheet, let's call it, to understand if the patient may have a sensory neural loss or a conductive hearing loss. It's not, of course, accurate like audiometry, but it's a bedside test that helps you decide this. For example, if you think about serous otitis media and you think there are some fluids behind the eardrum, you can do it and see if there is a conductive hearing loss, or maybe define if there is in one side asymmetrical sensory neural hearing loss and things like this. So Rinne and Weber tests are two tests that are used to it. So let's start with the Rinne test. So for a Rinne test, you need a fork of 512 hertz. I don't have it here, so I will use a pencil. So the idea is that you take the pencil, let's describe how it works, and then you understand what it does. So you take a fork, 512 hertz, and you just make it start to rotate or to vibrate, and then you take it and put it on the mastoid of the patient. He will hear, because it will continue to vibrate, he will hear a tee that will with time go and be more silent. And when he stops hearing it, you take the fork and you put it 2 to 3 centimeters from the external auditory canal of the patient. Now, in a normal state, what is called a positive Rinne, which is normal Rinne, the patient, after he stopped hearing throughout his bone conduction, you will just move it near his ear canal, and because the ear canal and the middle ear amplify the sound, he now can hear the sound again. This is normal, this is okay, this is normal. But if the patient has a conductive hearing loss, something just disrupt the wave propagation, he will hear the sound better on the conductive side compared to the air side. So normally he should hear it until he doesn't hear it on the conductive side, then you will move it and then he will hear it again. This is positive Rinne, this is normal. But if there is conductive hearing loss, you will keep hearing it, and when he stops hearing it, you will move it to this side, but he won't hear it. And this is called a negative Rinne. Now Rinne you do to both sides and test this conductive test, let's call it. Okay, so this was Rinne test, and you define for each side if is it positive or negative Rinne. Again, positive Rinne it's normal, but negative Rinne means that he hears the sound better throughout his bone conduction, and it means that there is probably a conductive problem. Now Weber, what he does, you take again a fork, you start vibrating, and you put it, for example, on his frontal bone if you want. Okay, when you do it, you hear the sound throughout his bones, so it goes immediately to the cochlea. Now normally he should hear the sound like in the center, not in this ear or the other. Normally it's in the center. But if there is a problem, he will hear it in one side and not on the center. So if he tells you that he hears on the left side, for example, on this side, it can mean two things. Or there is conductive hearing loss, so the conductive problem amplifies the sound. As we said, when you have a conductive problem, you hear better throughout the bone. So if there is a conductive problem in this side, he might hear better the sound on this side. But what will help you understand if there is really a conductive problem is the Rinne test, because if there is a conductive problem, Rinne will be negative. So Rinne and Weber comes together. But there is also another chance. If the patient has sensory neural hearing loss and the sensory neural hearing loss is worse on the right side, for example, on this side, okay, because you see it on the flip for what I do. So on this side, he hears worse in sensory neural, but there is no conductive problem. So on the Weber, he will hear better on this side. But what the Rinne will be? Rinne will be normal on both sides, what is called a positive Rinne, and normal Rinne. So in sensory neural hearing loss, the Weber will be to the side of the better ear. In conductive hearing loss, the Weber will be to the side of the conduction problem ear. So this is why it's important to do Rinne and Weber, because Weber alone, if it lateralized to one side, you don't know if it's conductive in that side or sensory neural on the other side. But Rinne tells you if there is a problem, a conductive problem, or not in that side. So this was about a Rinne and Weber tests. Very nice bedside examination to understand sensory neural and conductive hearing loss. Of course, remember, if, for example, there are patterns that won't be picked by Rinne and Weber, for example, symmetrical sensory neural hearing loss, Rinne will be positive, namely normal on both sides, and Weber, because it's the same symmetrical sensory neural hearing loss, it will be on the center, so it doesn't tell you anything. But if you have, for example, in one side sensory neural hearing loss, so Rinne will be normal on both sides and Weber will be to the other side. If there is conductive hearing loss on this side, Rinne will be negative here and Weber will lateralize to this side. So this is how it helps you, but in symmetrical sensory neural hearing loss alone, it may be normal Weber and Rinne. Thank you very much. This was about Weber and Rinne, and that's all for now.